Hello, this module talks about online cooperative learning. Uh, it is a little bit different from previous modules which introduced new theory. And in particular, the way it is different is that it talks about a general way of designing software. And it doesn't talk a lot about, uh, you know, how it changes how people learn. Um, this is because this module is sort of part two of this earlier module that you've already done on cooperative learning. So without further ado, here are the main learning objectives for today. We're going to talk about this particular way of thinking about software called a design pattern. At the end of this module, you'll be able to describe what a design pattern is. You'll also be able to articulate the benefits and limitations of design patterns. There is one particular pattern called this beyond being there pattern, which I want to take a deep dive into. Hopefully, at the end of this module, you'll understand this pattern, and you'll be able to apply this pattern to the problems of cooperative learning that you've seen before. So let's get started. To start, let us define a design pattern. This term design pattern comes from a book called A Pattern Language. It's a book on architecture by an architect, Christopher Alexander. And what it describes is this idea that there are certain problems which occur over and over again in our built environment. And these frequent problems, let me highlight a little bit here, problems which occur over and over again. And these frequent problems have common ways of solving it. What a design pattern does is it describes the core of a solution to this problem. So we already see two requirements for what constitutes a design pattern. First, it describes a problem which is frequent in our environment. And the second, it describes a core of a solution to that problem. Now, the third part is actually really interesting. It describes the core of a solution to the problem, but it does so that you can implement the solution, as Alexander puts it, 1,000,000 times over without doing it the same way twice. So essentially, it allows for a diversity in solution, diversity of implementation, if I may. And so, but in short, a design pattern is a reasonable solution or the reasonable core of a solution to a frequent or common problem. Let's look at an example of this, again, in architecture, which is where this term was first introduced. This is an example design pattern. It's called light on two sides of a room. It's perhaps Alexander's most famous design pattern. Here's the frequent problem that it talks about. The problem is that when people have a choice, they gravitate to rooms which have light on two sides, and they leave rooms which have light only on one side empty and unused. Note here that Alexander doesn't give you any evidence of this problem. That's because I'm excerpting from his book. If you read his book, there's a lot of evidence that he cites about why this is so. But for now, let us acknowledge that this is a problem. In fact, it's a frequent problem that occurs. Right now, for example, I am sitting in a room which has windows only on one side. And really, if I had a room which had windows on two sides, I would probably move to that instead. So this is a frequent problem. That is part one. Part two is the core of the solution. The core of the solution in this case is to locate each room so it has outdoor space outside it on at least two sides. This is the core of the solution. Now you can place the windows on both sides. I guess this whole part is the core, so that natural light falls into every room. Now, you can think of implementing this core of a solution in many, many different ways. And if you look around in many buildings that you've been in, you'll see that architects have implemented the solution in different ways indeed. So this is a frequent problem. This is a core of a solution. And Here is one particular example of how an architect has solved it. Here is one side of the room where there is light streaming in, and here is another side of the room where light is streaming in. And I have to say, this room looks a lot nicer than the room that I'm in. Given a choice, I'd probably move to this room. So uh, going back to our definition, here are the three parts: the frequent problem, the core of a solution, and implemented differently, or a diversity of implementations. I am shortening Alexander's definition a little bit. If you go read his book, you'll also see what has otherwise been termed an anti-pattern, like how not to solve this problem. One example is mirrors in a room, where you can pretend like there's light from two sides of a room, but it doesn't actually achieve the same purpose. It's much better to have outdoor light streaming in rather than have a mirror in the room. So this is one example from architecture which describes what a design pattern is. Now, I will say here that while this idea of a design pattern has been enormously influential in software and HCI, sometimes software and HCI people, when they talk about design patterns, they don't quite mean the architectural design pattern. The only reason you need to know this is because it's likely that you might collaborate with someone who has this more sort of colloquial idea of what a design pattern is in software. And they might think of design patterns differently than we talk about in this class. So in a colloquial fashion, when you're talking about design patterns in software, it usually is this general reusable solution to a common problem. What this leaves out is this emphasis on being able to implement it in different ways, right? So remember, Alexander talks about you can implement the same design pattern 1,000,000 times over and never do the same thing twice. That notion is frequently lost when you talk about design patterns in software and HCI. Often, design patterns, the term design pattern is used to mean just a codified best practice. So this is one way of doing it. And instead of thinking of, here are all the ways that you can implement the core of the solution. You can see the results of this in software libraries or components, which implement one way of solving the problem in the design pattern, but they are only one way of doing it. So if you only have one way, then it becomes a software library or component. It takes away some of the elegance of the idea of a design pattern, in my opinion. But for the rest of this module, and actually for the rest of this class, we're going to talk about design patterns in the sense that it is used in architecture, where it describes a problem, the core of a solution, and allows you to implement that solution in many different ways. So what is the benefit of using a design pattern? There are two large benefits. One is that it helps you start noticing these problems about your environment. When I learned about design patterns and about this idea of light on two sides of a room, I couldn't stop noticing all the rooms which had light on two sides and how much better they felt than rooms which had windows only on one side. I'm sorry, maybe this is something that's going to happen to you over the next couple of weeks. You may be increasingly frustrated when you see yourself in a room without any windows at all, or with windows on only one side. It has this idea of this design pattern has helped you notice this problem that many rooms don't have light on both sides. So that's the first benefit for design pattern. It helps you notice problems. When Alexander wrote his book, he aimed it at non-experts. He wanted everybody to be an architect. But the more and more design patterns have influenced practice, both experts and non-experts have seen themselves benefiting from this idea of noticing important problems in their surroundings. So that's the first problem. The second problem is that if you've never thought of how to solve a problem before, you might do a good job, but it is unlikely that you would reach the optimal solution immediately. It is also very likely that you will reinvent somebody's previously discovered solution and actually do a poor job of implementing it. I call this the idea of reinventing a flat tire, where it'll be okay if you reinvented the wheel. At least it works okay. But if it's the first time that you're inventing something, chances are you won't get it right. And instead of reinventing the wheel wholesale, you'll probably invent something like a flat tire, which mostly works, but is also somewhat uncomfortable and annoying. So what this idea of a design pattern does is that once it helps you notice the problem, it gives you the core of a solution. And that core of a solution prevents you from finding yourself in a suboptimal solution. It gives you a good enough solution that is useful for a frequently occurring problem. Now, there are limitations. The two big ones are, one, while it guarantees a good solution, it doesn't guarantee it's the best solution in every circumstance. For the most part, it is still better than inventing your own solution, but sometimes you may have an idea which is much better than the design pattern. In that case, that sounds good. Check against some of the design patterns that you learned before, and if it really is the best solution, that's great. The other problem is that, so this is one, the other problem is that even in Alexander's book, there are multiple ways of solving a common problem. They're all good solutions. So unfortunately, what happens with the design pattern is you don't have a very good way of comparing these solutions in a principled way. If you find yourself in such a circumstance, it is best to prototype. Think of the different ways or look at all of the different design patterns that might help you solve that problem and try them out in a low-cost fashion. If you find your learners benefiting more from one design pattern than another, that's the one you want to use in your particular situation. All right, so we've talked a lot about design patterns. Now I want to go back, and we've also talked about the benefits and the drawbacks. Now I think it's time to talk about this design pattern that I mentioned earlier, called the beyond being there pattern. As a reminder, a pattern talks about a frequent problem and describes core of a solution and allows flexible implementation. So the beyond being there pattern talks about a flexible way to implement online mechanisms for communication. It isn't particular for learning, but a lot of online learning, online cooperative learning, involves people communicating with each other. The beyond being there pattern is a pattern for designing online communication. This pattern was first articulated in, I think, 1992. And at the time, the internet was just the twinkle in some researchers' eyes. It wasn't quite the mainstream thing that we see today. In fact, I pulled up an old magazine article on what the internet looked like at that time. Here is a Q&A about the internet. There's only 30 million other users, for example, not the billions of people that we have online today. And there's only a small set of things that you can do. And for example, it says, is it complicated? Yes, it is complicated because it's so new. Against this backdrop, there's two researchers at Bell Labs who are trying to design online communication systems. That's Jim Holland and Scott Stornetta. They wrote this paper about how to design software for telecommunications. They start with saying, hey, in this world where telecommunication is getting a little bit better every year, it is tempting to think that with just a little bit more screen resolution, just a few more tweaks, we'll have telecommunication systems which achieve a level of information richness so close to being face-to-face that for most needs, it will be indistinguishable. And this temptation is where part of this title comes from. Essentially, the temptation is that with just a little bit more technology, you being online can become as good as being there, right? So this is a temptation. And as good scientists, Jim Holland and Scott Stronetta have done a lot of work on this, and they find something else. I actually encourage you to read this paper. It is in this week on optional readings, but you don't need to read it in order to understand the rest of this week's learning objectives. So what Holland and Stronetta talk about in their paper is that there's this very strong temptation to try and tweak online communications just a little bit more, such that they're identical to the feeling of being somewhere. And so they want to say, but unfortunately, this temptation is a false goal. And in particular, they say that when you have a choice between being face-to-face and an imitation of being face-to-face, no matter how good the imitation is, it is natural to choose the real thing. So the focus on replicating the in-person experience will inevitably lead to failure, because if the imitation is just half as good as the real thing, you're not going to use it half as often. We'll probably not use it at all. So what do they suggest instead? Instead, they suggest think of both the online world and the in-person world as just media. Like we design something for an in-person media, design similarly for online media. And I'll make this a little bit more graphical here. So this is my drawing of a globe, and this is our idea of what it is online. So here you have the physical world, here you have the online world. The temptation is to make this online world as similar to the physical world. Instead, what Stronetta and Holland suggest is think of all of the properties that you could have online. So for example, you could have the property that this could be asynchronous. You don't have to be present at the same place at the same time. You could be anonymous. Oh, this stopped working. Anonymous. So people do not need to know your name before you communicate with them online. You could communicate with lots of people all at the same time, which you can't do in the physical world because rooms can only get so big. So here are all of these properties of this media. These are different. These are unique properties that you won't see in the real world. So if you're trying to design something online, don't focus on the properties which you're trying to match to the real world. Instead, focus on all of these other properties, which can give you different benefits, which can allow you to design differently than you would in the in-person setting. All right, so let's look at one example of what we mean here. A few years ago, we did this research project in our lab, and in some sense, it was the online version of the Jigsaw learning module that you've seen before. As a reminder, you have all of these media properties that you can get by being online. And in our research project, we focused on just one of them, the idea that the computer could determine who you talk to, right? So in the physical version of the Jigsaw exercise, your teacher in the classroom is probably going to tell you how to form groups. Online, you could have an algorithm do that instead. So that is a particular property that we used, and we created a system for online Jigsaw in some sense for large online classes. These were classes offered by vendors like Coursera or edX. And the particular problem that we tried to solve was that students in these online classes were homophilic. Homophilic essentially the fancy way of saying that you like or you're attracted to people like yourself. So here is some homophily on display. Students often make study groups for other students from their own country. So you could have a study group just for Indians, a study group even for just Romanians, which have to be much fewer, I think, in this online class. There's also other kinds of affinity groups or homophilic groups by language, for instance, or by culture, or cultural language, like for Latin America. As you might remember from our jigsaw exercise, it is better to have people talk to folks who are unlike themselves, such that they can develop some empathy, such that they can learn from each other's experiences. So what we did was we created an online version of a jigsaw, and instead of allowing the teacher or asking the teacher to do the algorithm, to do the group assignment, we got a computer to do it. What students would do is they would first choose a time. For example, I will choose this time, I will join in for this discussion. And what the computer would do would take all of the people who signed in for that discussion, and then it would create a jigsaw group algorithmically based for a subset of the people who have joined in at a particular time. Now, because you have a computer algorithm doing this, you can do it much faster, and you can also use a lot of data, different data, than you might if you were to do it as a teacher. For the most part, this worked quite well. I want to show you just a couple of these results. So here is a few of the students who participated in this discussion talking about it. A lot of the things you would expect as you might in a jigsaw classroom. So for example, here's a student who says, at the very start, you think you're the only one with a particular challenge, and then you realize actually everyone has the same challenge. So you can see the student developing this notion of other awareness, which might lead to empathy down the road. You also see sort of this idea of bringing together people, not just based on, for example, demographics, but prior knowledge. So here you have people with both a business-minded background and a technology-minded background. And you can see that that has allowed people to learn from each other's experiences. So you can think of the benefits of diverse experiences. You can also think about maybe this might lead to greater empathy. This comment doesn't tell you exactly that, but there's potential for it. I can go on and talk about this research project. I think it was one of my favorite research projects in a while. But for now, I think what I want to highlight here is that it is taking this medium of being online and using its specific properties, the properties that you can do algorithmic assignment to groups, and using that property in order to improve discussions. You could have a discussion system like this in the physical world, but then you would be limited to the number of students that you have in your own classroom. What you can do with an online system is perhaps you could connect people across classrooms, and as we did in this particular project, across countries. So you can see the benefits of going online as, in some sense, going simply beyond being in a classroom. In some sense, it allows you to go beyond being there. All right, so that's one positive example of this pattern of beyond being there. Here's, in my mind, a negative example. Blackboard has a feature, they call it the Blackboard Collaborate. What it allows teachers to do is to ask students to participate in an online discussion about a class topic. And what students can do there is, for example, raise their hand. Teachers can then call on students, see who was first, and so on. In some sense, this is Blackboard trying to replicate the physical classroom as closely as they can. And when they do that, you can see that as being a violation of this beyond being there pattern. Given a choice between participating in this online Blackboard collaboration and coming into class and having the same kind of collaboration, it's reasonable to expect that many students would choose the in-person version instead. So we've talked both about positive and negative examples of this pattern. So as a final note, I want to just describe this in some more formality. Here is the pattern drawn up. Here is the frequent problem. The frequent problem is that given a choice, people will gravitate to those spaces, whether they be online or offline, where the spaces have mechanisms that are designed to meet their needs. And it called this mechanism, which is essentially a design of interaction. So if the online space is better suited for a particular kind of interaction, they will go online versus in person. If some other interactions are better suited, you go in person. So that's a frequent problem. If you are a designer who wants people to use your solution, your system, then the core of the solution is you want to design these interactions, these mechanisms, which are these interactions that people can do in that particular medium, such that they meet user needs using properties that are unique to that medium. So for the online medium, it would be something like asynchronicity, being always available, and so on. All right. I have elided here what I mean by user needs. In the case of cooperative learning, these user needs would be things like, and you've already seen this in a previous module, the ability to design for individual accountability, the ability to create positive interdependence, and more. So there's a beyond being there pattern as you would want for cooperative learning. So at this point, we've looked at all of the learning objectives for this module. Before you go, I just wanted to point out that this particular design pattern can be used for more than just designing online cooperative learning. Here is an example of using it for a completely different non-learning application. Here's a social network. It's called Nextdoor. It allows you to see activity that's happening in your neighborhood. If you were to replicate what would happen in the in-person neighborhood, you might have a meeting at a particular time where everybody in the neighborhood comes in and shares their news. What Nextdoor did was to use the properties of the online medium. For example, they're using the property that the online medium is always available and you can access it from any device. So always on and accessible from anywhere, right? And so that allows you to design these interactions such that people can share news that they wouldn't be able to share if they were waiting for the next neighborhood meeting. For example, look at this news where they're talking about this poor lost cat. If you wait until next month's neighborhood meeting, your furry friend Buddy may not be able to find their way home until then. So you can see how you can use these ideas of beyond being there, not just for learning, not just for cooperative learning, but for entirely different applications. As the last thing today, we've talked a bunch about different applications or different products which try and do cooperative learning. Duolingo Clubs is one among them. In class, we critique Duolingo Clubs for its design of individual accountability, and positive interdependence. You can also think about how you might redesign Duolingo clubs or features like that to use the properties of the online medium. All right. So we are at the end of this module on online cooperative learning. In the next couple modules, we'll look at some other examples of learning online and some other design patterns from there.